Hi dear students, in this video I am going to explain the AC and DC analysis of BJT common amplifier using LTSpice simulation software. This is the circuit for BJT common emitter amplifier with voltage biasing. The circuit requires 4 resistors R1 and R2, R1, R2, RC and RE. RC is the collector resistance, RE is the emitter resistance, and two coupling capacitors as required. C1 as input coupling capacitor and C2 as output coupling capacitor, and CE is the C3 is the bypass capacitor, and this is the R5 is the load resistor, and we required two voltage sources V1 and V2. V1 is the DC source and V2 for AC supply. Okay. Now coming to the LTSpice, make the circuit as shown in figure. This is the circuit, and make the connections as shown in figure. Put the components values by clicking right clicking the component. Here here R1 I selected as 33K, and could name the component as R1. Similarly, for each resistance, here RC is the 10 kilo ohm resistance, and I labeled it as RC. Similarly, R2, RE, and R5. Then coming to the coupling capacitors, I named it as C1 and C2 just by right clicking on that. Put name as C1. Here I put name as C2. For providing values, right click on this and provided 10 micro. For getting micro symbol, just put U, then it will automatically reflect into micro. Similarly, I provided values for component values for C1, C2, and C3. Then Q1, all components will be available in this component menu. That part's already know. That's why I'm not explaining that. Then ground the circuit. Two grounds are required. Here one ground and here another ground. Then I selected the transistor as NPN transistor, or I can select specifically any type of transistors, BC547B or anything I can choose. And after making the connection, put labels. Put labels as how to put labels. How to put labels means place the cursor here and right click on that part and click the label head. Or it's also available here in this part, label, or whichever we want label, right click on that and go to label net and provide the label name. We in and place it wherever we require the label. Similarly, I provided the labels VB for base voltage, IB for base current, VE, IE, DC, IC, and Vout. The same procedure I followed. That's all about the circuit. Here here for V1 I provided a DC value of 50 volt. Initially I am going to explain the DC analysis. For that, we doesn't require the V2 because we only needed this V1 DC supply. Actually, DC analysis is for finding out the operating values of the BJT common emitter amplifier. Means the values of IB, VC, all things we can find out using DC analysis. So for DC analysis, I doesn't require V2, so I put blank. Here. Okay. Then for DC analysis, go edit the simulation command and go to DC operating point, and we need a dot OP. Click OK. Then just click on the run icon. Then we can see the operating point. This is the output of DC analysis. All values we can, it's available. VC, IEB, VC means collector voltage, IB means base, IB, IC, IE, IC, B in, B out, all values are provided in a single sheet. This is the DC analysis. IE. Okay. We did this DC analysis for getting these operating points. We can mark that values on the circuit. How to mark it means if I want to show the V1 value, right click on that part and place .op data label. That is all operating points we can also provide on the circuit. Similarly, IC, what's IC current? IC current, how much is the IC current? Right click on that, place .op data label. This is not correct, so right click on that. Remove the $sign and select the proper data. Here it is IC for Q1, IC for Q1 transistor. So IC Q1, select IC Q1 and click on OK. This is the collector current. And similarly, mention all the operating points. What about IB? Here I right click on that, place .op data label. This is the IB value. If coming the question mark, don't worry, just right click on that, remove the $sign and select the proper one. This is IB, so select IB for Q1 and click on OK. This is the IB value, IB current. Similarly, what about IC? Sorry, IE. right click here, right click, place dot ob. You can rotate by clicking Control R. Right click on the question mark and remove the dollar sign and select the proper one. This is IE for Q1. Here you can see the values. You can compare the values IC and IE. Here IC and IE are approximately similar but in opposite sign. And what about B in here? I didn't provide B in. How I click on that? 0 volt. Nothing I provided here. Actually, I nothing provided. So it's showing 0 volt. What about V out? Right click on that and place V out. Remove the dollar sign and select V out. V off, V out. This is the output voltage. And similarly, I can by using this DC operating point obtained from the DC analysis, I can label all the DC operating values on the circuit by right clicking this and by taking the place dot op data label. Okay, this is the all about DC analysis. Then coming to the AC analysis. Coming to the AC analysis. AC analysis is to find out is to check whether amplification is happened. Actually, this is a BJT common emitter amplifier circuit. So we need to check whether amplification happened or not. That we can analyze using AC analysis. And also to check the frequency response of the circuit. So for AC analysis, we need to do two things. First one to check the amplification, and second one to find the frequency response of the circuit. So to check the amplification, I need this one B2. I have to provide an voltage AC source here in B2. So click on that B2, click the advanced, provide a sine wave, some DC offset as 0, amplitude of 20 millivolt, and frequency. Randomly I am putting a low value signal, low amplitude value signal I am providing. Just need to provide these things only. Click on OK. So here I am providing a sine wave of amplitude 20 millivolt and with a frequency of 1K. And this low value sine wave, how to amplify, and an amplified output signal will be available in this Vout session. Okay, so go to the edit simulation command and just provide stop time, just 5 millisecond. Then click on run. Make the view as vertical. and provided two plot pins, one for input and another for output. First one I am clicking this input section. This is my input voltage, sine wave. We know its amplitude is 20 millivolt and x-axis is time. That's why I provided 5 millisecond in the transient stop time, and click on the second plot pane and select the output. We can see the variation in the input and output, whether it is amplified or not. Here the amplitude is 20 millivolt. In the output session, it is amplified into 2 volt. 20 millivolt amplified into 2 volt. That means it performed the amplification. This is how we can check the amplification using AC analysis. Then going to the second part of the AC analysis to find out the frequency response of the BJT common emitter amplifier. It's also very simple. Go to edit simulation command and remove this transient stop time and click on AC analysis, select a decade and provide the number of points per decade as 10 and starting frequency, because here we are analyzing the frequency response. So provide starting and stop start and stop frequencies. Start frequency just provide 10 hertz and stop frequency as higher than start frequency. That I'm just providing 100 megawatt. And also we need to change the V2 source values. Right click on that and click on none, remove the sine wave and provide an AC small signal AC analysis, AC amplitude as 20. Click OK and run that. Click on run. And right click, add a trace and select V out. V off, V out. V off, V out. This is the frequency response of the BJT common emitter amplifier. Here this part shows the magnitude plot and this dotted line shows the phase plot. You can see here the x-axis is the frequency and y-axis. For the magnitude plot, y-axis is the gain. So this graph is frequency versus the gain graph. That is, this is the frequency response characteristics. And I'm removing the phase part. So right click on this part and don't plot phase. Remove that one because I only needed this magnitude plot. That means the low frequency is the 10 hertz and maximum I provided the stop frequency as 100 mega. That's why this x-axis shows the variation from 10 hertz to 100 megahertz. So this is the frequency response of the common emitter amplifier. So that's all about the AC and DC analysis of the BJT common emitter amplifier. In DC analysis, I found out the DC operating points, and in AC analysis, I checked whether amplification happened or not, and found the frequency response of the amplifier. Okay, thank you.